Okay guys, so what we're going to be doing next is we're going to learn how to draw Lewis structures for compounds. Now, so we have our periodic table right here. So what we're going to be doing is we're going to be counting the number of valence electrons. So group 1 has 1 valence electron, group 2 has 2 valence electrons, 3, 4, 5, 6, 7, and 8. Okay, so you can't have more than 8 valence electrons. That's called the Octet Rule. So as we're doing these, we're going to be identifying a central atom, and we're going to be drawing Lewis structures based upon the number of electrons things have. So usually the further to the left, the more it's going to be a central atom. Like carbon a lot of times is going to be a central atom. And then you can tell which one's going to be the central atom if there's more than one thing involved. Okay, so just kind of keep that in mind as we go through. You'll kind of get the hang of it as we go. Okay, so our first step is we got a carbon. Carbon has 4 valence electrons. So carbon, we got 1 times 4 is 4. Hydrogen, we have 3 hydrogens, and hydrogen's in group 1, so we're going to have 3 valence electrons. Chlorine's in group 7, and I have 1 of those, so I'm going to have 7 valence electrons. Okay, so 4 plus 3 is 7 plus 7 is 14. I'm going to divide that by 2. I'm going to have 7 bonds total, or lone pairs of electrons. Okay, so when we go to draw this, carbon in this case is going to be our central atom. Okay, and we have to have 7 bonds total going, or 7 pairs of electrons. So I have 3 hydrogens involved, so I'm going to draw 3 hydrogens going off the central atom. And then the chlorine is out to the side. Now, I have to go figure out my valence electrons. So hydrogen can only have 1 valence electron, so these are all good. Carbon has 4 bonds because it's in group 4, so it's 1, 2, 3, 4. And then I have to fill in my lone pairs of electrons for chlorine. Chlorine has to have 7, so I'll put a lone pair of electrons here, here, and here. And then to make sure I did my Lewis structure correctly, I count the number of bonds or pairs of electrons. 1, 2, 3, 4, 5, 6, 7. Okay? And that is the correct Lewis structure for this. Now, if you see it with lines like this, you can write it with lines. That means a lone pair of electrons when you connect the dots. This would be a polar molecule. Just keep that in mind as we go through. A polar molecule means that you have lone pairs of electrons. Next example, this is propane. So carbon, you have 3, and carbon is in group 4, so it should have 12 electrons. Hydrogen is in group 1. You have 8 times 1 is 8. You add them together, you get 20. So you should divide it by 2, so you get 10 bonds total. Now, like I said, carbons are probably going to be the central atom, so I'm going to put carbons, and I'm going to connect all 3 of them in a row like that. Now I'm going to fill in my hydrogens. Carbon can have 4 bonds total. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I have 3 carbons and 8 hydrogens total, and I'm going to count my bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bonds total. So that is my Lewis structure for propane, C3H8. Next one. Carbon, I have 1 carbon, it has 4 electrons. Hydrogens, I have 4 total. And oxygen, I have 1, and it's in group 6. So I do it like that. Add them together, 8 plus 6 is 14, divided by 2, so I should have 7 bonds total. Okay, so carbon's going to be our central atom. And hydrogens are probably going to be coming off like that. Okay, so I gotta go fill in my hydrogens. So 1, 2, 3. Hydrogens coming off this one. And I have one more hydrogen that I have to take care of, so it's coming off the oxygen. Okay, so I have to have 7 bonds total. 1, 2, 3, 4, 5. Oxygen's got to have 6 valence electrons, so I have to put in 2 lone pairs like that. Now, just an FYI, chlorine we've done. So chlorine's in this group right here. Most of the things in this group are going to have 3 lone pairs. As I go this way, 2 lone pairs and 1 lone pair, okay, of electrons. Just keep that in mind as far as trends. Okay, C. So carbon, we got 1 carbon at 4. Hydrogens, got 2 at 1. And oxygens, I got 1 at 6. So 4 plus 2 is 6. 6 plus 6 is 12. Divide that by 2, so I should have 6 bonds. Okay, so we're probably going to do a carbon connected to an oxygen like that. Now I have 2 hydrogens coming off. Okay. Now, what am I going to do with the rest? I have to have 6 bonds total. Well, carbon's going to have 4 bonds total, so I'm going to put in a double bond right here. And going with what I just said about oxygens, oxygens is usually going to have 2 lone pairs of electrons. Okay, so I'm going to count the bonds to make sure I did this correctly. Carbon's in group 4, so it has 4 bonds total. 1, 2, 3, 4. Oxygen has 6. 1, 2, 3, 4, 5, 6. So this is the structure for CH2O. Okay. Next example, chlorine. Chlorine is in group 7, so you got one of those at 7. Fluorine is also in group 7, and you got 3. So I get 28. 28 divided by 2 is 14 bonds total. So your central atom in this case is going to be chlorine. And I have 3 fluorines coming off of it. Now, going with what I said, if it's in group 7, it's probably going to have 3 lone pairs of electrons. So let's go ahead and fill in our electrons. And I'm going to connect the dots. Okay, so I need 14 bonds total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing 3. Now, chlorine has to be in group, it has to be in group 7. So it's going to have 7 valence electrons. Right now it has 3 because it has 3 bonds. So it needs 2 lone pairs of electrons. You can put it coming off of either side, doesn't matter. So let's go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bonds. Okay, so we're all good to go. pH3, P, you got one of those, and it's in group 5. H, you have 3 of them, it's in group 1. So you should have 8 total electrons, which means you have 4 bonds total. So I'm going to put P as my central atom, and I'm going to draw 3 hydrogens coming off of it. Hydrogen has 1 valence electron, so it's just going to be like that. Now P has to have 5 because it's in group 5. So I have 1, 2, 3, and I get the 4, 5 by the lone pair of electrons. Okay, so I have 4 bonds total. CO2. Carbon. I have 1 carbon, it's in group 4. Oxygen, I have 2, it's in group 6. Okay, so I have to have 8 bonds total. Now, like I said, carbon's probably going to be the central atom. Okay, so carbon is usually not going to be a polar molecule. And when it bonds to oxygen, it's usually going to form a double bond a lot of times. Okay, so what I'm going to do is I got to get these bonds. So it's going to form a double bond. So 1, 2, 3, 4. Carbon's good to go. Oxygen has to have 6. So like I said earlier, oxygen's usually going to have 2 lone pairs of electrons. If you keep that in mind when you're doing this, it'll make your life a lot easier and to figure these Lewis structures out. So I should have 8 bonds total. 1, 2, 3, 4, 5, 6, 7, 8. And we're good to go. HCN. Okay, H. I got 1 H, it's in group 1. Carbon, I got 1, it's in group 4. Nitrogen, I'm in group 5. So I should have 10 and 5 bonds total. Okay, so carbon's most likely going to be a central atom, and I'm going to put a nitrogen and the hydrogen off to the side. Now, carbon's got to have 4 bonds total. Can't get anything over here because hydrogen can only have 1 bond. So I'm going to make this a triple bond. Okay, you can't have greater than a triple bond. Okay, so carbon's good to go. 1, 2, 3, 4 with carbon. Now nitrogen's in group 5A, so it has to have 5 valence electrons. It has 3 already, so I'm going to add the 2. And then I should have 5 bonds total. 1, 2, 3, 4, 5. Okay, so that's the Lewis structure for hydrocyanic acid, HCN. So when we're doing this, just simple trends. 3 lone pairs, 2 lone pairs, 1 lone pair in group 5A. Now, this group forms triple bonds sometimes. This group forms double bonds sometimes. And these are always single bonds, usually. Okay? Hopefully this helps clear up some of these Lewis structures. And we'll come back with another set of practice problems. Thanks.